So speaking of silicon, so those of you who know of me a little bit, prior to my working in type design, I was a semiconductor process engineer for about 10 years. My particular area of expertise was photolithography, which is the process of imaging the circuit patterns which come off a photomask, which you see in the middle, into a photoresist layer that's coated onto a wafer, a silicon wafer, and that image gets subsequently used for, as a mask for etching or a mask for ion implantation. But the thing with photolithography, it's actually just one step of many steps. So it's one process nested inside another series of processes to make up an entire transistor. So here's kind of a cross-section of a CMOS transistor, pretty basic one. And you can see there's a lot of stuff going on. So here's kind of all the materials that you end up having built up to make this thing work. Points, if you recognize that I mislabeled the spacer materials, but but you can imagine, so if we have all the variables from photolithography, you got all the variables from physical vapor deposition, chemical vapor deposition, dry etch, wet etches, chemical mechanical polishes, diffusion operations, anneals, all these things are compounding, and so it makes there's a lot of ways that can go wrong. But remarkably, this works very, very well. We have high success rates when manufacturing semiconductors. And some of the reasons that is that one is in that development of that process, we have a really high comprehension of the failure mechanisms, and we do a lot to mitigate the variables. And then there's already safeguards built into the process so that it's more robust to kind of eliminate some of those sources of variation. But the thing is, making a semiconductor is only one part of a bigger process, which is making semiconductor products, right? You don't just make a transistor for fun of it. You need to do something with it. So once we have a manufacturing process developed that delivers certain kinds of device characteristics, any number of designers can go then choose that process to design any number of designs of circuits or like functional products and do all sorts of different things. So there's a lot of so we had the variables from the manufacturing, but now we have the variables in how to get to, producing products of a variety of different things. So this starts to look a little bit like what we do, right? So we got users who are using some methods of composition in a computing environment to generate documents, right? This is kind of their little text interchange thing. When that document goes to someone else, we've interchanged it. And so this is kind of what I want to talk about, is the control of processes, and maybe some of the things I guess I'm seeing as to why we have kind of high failure rates in this process. So it kind of starts, we've got to map out the process. So at a most basic level, this is what we're doing, right? We have user A, they're creating a document. In the process of creating the document, they're being presented back that text in some fashion. And then when they're done with it, they shoot it off to be interchanged to user B. If we blow this up, I just want to mention, in this context of this discussion, I'm calling anything a document that's a kind of a body of text you're sharing with somebody. So it could be a book, an article, web page, social media post, email. So all those I'm calling documents. So we kind of open this up. And as I go into this, I see obviously people in this room that are way more familiar with this process than I am. So, at some point, correct me. I'm sure I got some things wrong, but I'm trying to map things out in a way people can understand. So there's some critical operations that come in play, right, to do this operate. It's not just one step, right? And so the first thing that has to happen is the user starts with some kind of input method, right? And the input method could be a physical keyboard, a virtual keyboard. It could even just be like copying and pasting glyphs into a thing. But what's important is that what they're actually sending is a string of code points to some kind of client app. That client app can be any number of things, but it needs to then know what to do with that string of Unicode values. So that's where the real kind of secret sauce starts kicking in. So we kind of have this secret series of events that happen, kind of all under this sort of semi-shaping umbrella. But you got to analyze those Unicode code points, figure out what to do with them. There's a lot of these character properties associated with it that have to get fed in and figure out how to process that. The text has to be parsed and broken up into pieces for it to be analyzed and processed, and it hands off to a shaper, which is actually going to go do all the things where you need to reorder glyphs or substitute glyphs or reposition glyphs. And then an OT layout processor is the open type part of it, where it needs to go and find those relevant open type code that's in the font that is responding to the moving of glyphs or replacing glyphs. And I should point out that we call this kind of this shaping engine thing. It's there's actually multiple pads inside of it. You could have pads that are dependent on scripts. So some scripts shape in a whole different path than other scripts. You can have pads that are related to just for rendering efficiency, just to go faster than other ones. You can have pads for legacy reasons. So you already have a certain kind of variation here. And then finally, you kind of hand it off to a rendering engine to turn it into pixels to display on screen for the user. So if we blow this up again, we can start looking at some of the process inputs that go into each of these steps. And so I kind of lay these out on the right. So we start with the specs, right? We have the Unicode spec, which is the backbone of this whole thing. It's not just code points. It's a lot of character property data. There's also all these additional things like Arabic shaping.text, what to do with bidirectional text, some script extension data, text segmentation. There's all sorts of things that go in here, line breaking. And then there's also the W3 spec, which kind of deals with some of the presentation stuff on web. There's all this kind of supplementary data, right? So you have, you may need your ISO 639 language tags for a document, an app to know what language you're working in, which may enable certain features. You have font fallback, which can occur if the font doesn't have the glyphs you need. And then there's some shapers that just use supplementary character data that's not strictly part of the Unicode spec. And then we have the font itself, which is not only got the outline data, it also has the metrics data, the side bearings, the vertical metrics. So that information is all in there. And then I kind of wanted to point this out because there's like a cyclical thing to this. If some new features depend on what we produce for documents. So if we're looking to create lexical models for predictive text, spell checker, grammar checker, we need to have documents that we've created in some fashion to feed into training those dictionaries and models for future editions. So the quality of those documents, is important for future editions or future enhancements. And then I just want to point out these green lines. They're just sort of like cross references within a process input. So like for a font, the font also needs to know the Unicode code points, some of the character properties, as well as things from the OpenType spec. So what immediately stands out here is that there's this thing I'm calling optional, right? Some of these inputs go into these process steps, and it's maybe partly by design, but a client app doesn't really have to do everything that the shaper can allow it to do, or a shaping engine makes available to do. It can choose to do things its own way. There's no real actual enforcement. Generally, you don't want to do that, but there are reasons to do that. There are other optional things that are kind of innocuous, like if a keyboard doesn't have a predictive text input, well, it's just a feature that's not there and that doesn't hurt anything. But it's these optional ones, I think, where we start to see some kind of problems occur. So if we kind of compare this to our integrated circuit and design and manufacturing process, it kind of looks like this. And I wish I had time to actually drill down into all this, but I don't. So just take my word for it. This is how it works. That fabrication column, that is just that cross-section that I showed, right? But we have to do everything from the designer getting from there into a packaged product that they can put into a device. So, but one of the things, two key differences I see stand out here is one, there's no optional way to do anything. There's just one way to do everything. It works one way, it's spec'd that way, you get from point A to point B in one way. The second thing is these things I've highlighted in brighter blue in the right column, those are all validation steps, every one of those. So you cannot go from one of these critical operations to the other without having had conducted some kind of validation to make sure the variables are sort of under control. And so I think this is kind of some things that we see. And so I kind of want to show some of the problems that we see. And I have on good authority that some of these are going to be fixed very soon, so I'm not here to harp on the errors themselves. What I'm concerned is about how we get to why the errors happen. So the first order effects are things that they're just attributable to a single cause. So sometimes we see lagging updates across shaping engines. So Unicode spec comes out with some new stuff in it, new characters, but the shaping engines have not been updated. You get varied updates across different platforms. So user experience can vary depending on what they're doing. Another thing is just sometimes little errors in implementing the Unicode properties. So this odd-lum nasalization mark, it should be connecting underneath. It's a shaping character. It's defined to be so in Arabic shaping.txt, but it doesn't actually do it, and so you end up having there's no line underneath it, and those characters shape like they were separated. And then, but really the big thing that concerns as a process engineer is these second order effects. These are things that are caused by some kind of interaction, right? Because these are the ones that are trickier to kind of nail down. So a lot of these bidirectional failures we see, so here's this Arabic text, this period that should be at the end of the sentence, does not, it goes to the end of the first word, last word on the last line. You cannot get that over to the other side. It's really frustrating. This is a problem that also occurs with odd-lum. So, and it's so problematic so that users are starting to just use like a Farsi stop instead of a period as a workaround because it's got a strong right to left behavior, but that's not what we intended for them to do. Another thing, the bidirectional category is this this lack of mirroring of these quotes. So this is a web page in odd-lum. I checked the attributes on the page do say right to left. I don't believe there's anything in that string of text that has strong left to right properties, but for whatever reason, something is interacting with something else, and those quotes are not actually performing in the right direction. Wrong shaper. Okay, so this is, I was trying to make a slide for this, which I didn't include, but I was trying to type this string of Go to make the presentation. So on the same platform, different application, can't get the one in the right to actually go right to left and shape properly at all. Don't know why. Something is, maybe the bidirectional algorithms are off, or maybe I don't really understand what's happening here. Another thing we see is just really aggressive font fallbacks. If users going ahead typing their thing, they've chosen their font, and as soon as they start to type again, it just switches to a system font. And so there's this iteration of typing a little more, select all, change your font, type a little more, select all, change your font. It's really a frustrating exercise. And then sometimes we see this interact with script itemization. So you can see here this text should all be in a brima, but only the Unko letters themselves, strictly Unko letters, are coming up in a brima, but all the common kind of things like spaces and punctuation are coming up in a system font. So there's definitely some odd things happening here. So kind of some observations about these errors, right? They're not caused by unexpected user input, right? These are things that we would expect to work because there's the kind of how we have defined these things to work. They tend to be in gray areas more often than not, right? So there's glyphs that are used with many scripts, bidirectional text, things that are not as straightforward. But the thing that stands out to me is that the implementation is causing the errors, right? These aren't random errors that, as implemented, the errors are being created. So whether it's just not getting the current specs accommodated for or not, or just but mostly unaccounted for interactions. So the impact for users obviously is massive productivity loss, right? Sometimes you're doing, and I have to do this myself when I'm preparing specimens for things. You kind of bounce between different applications, typeset the text here, maybe outline it here, get one thing to work somewhere so you can take it somewhere else to use it in a better way. And then you spend a lot of time looking for workarounds. Users also expect these things don't get repaired very quickly. And it's not that no one's trying. Everybody wants these things fixed. But the priorities for writing systems that aren't as well supported or kind of they're not always the highest priority to get fixed in the most timely fashion. I mentioned these workarounds. The workarounds I think are really the real damage here, because if the whole point of text interchange is that it's universal and it's working everywhere, but then people are doing workarounds that differ by how they do it, then we're sort of undermining the whole point, right? Like, if some people's using this kind of punctuation instead of this punctuation, inserting different things in this as they're typing in different ways, that sort of defeats the whole purpose. And then as a result, they just have really low confidence in achieving parity with the Latin script. So if we look back at these processes, just to summarize these notable differences, in our sort of document creation process, we have this fragmented workflow. We have different shaping engines, different pads, different things that are optional, different ways you can implement things based on application. And as a result, the variation in one operation bleeds into another operation. We have minimal in situ validation going on. There is some shapers that will do cluster validation, so that's a little bit of something, but there's really on the whole not a lot of testing going on between handoffs. And then finally, failures are discovered by bug reports. And I say this as a process engineer, I hate bug reports. Saying this, knowing that I owe some of you bug reports. But what I don't like about it is, why I don't like it, is a bug report in my world it's a failure in the field. That's, it shouldn't have gotten there, because especially things that we know should have worked correctly the first time. The other problem is bug reports, I think, drastically represent the frequency and the severity of the problem. Because after you spent a bunch of time messing around with something to get it to work and you lost a lot of time, the last thing you want to do is submit a bug report. If you found a workaround, you're probably going to lean on that heavier. So the differences on the IC design and manufacturing side is that we don't really have these issues. And when nothing gets to the end unless you've tested it. And you know what your outcome is, you've tested it, we call that yield. If anything that fails that, it's scrapped, it's gone, and you don't ship that to a customer. So there are differences. But I can appreciate that there's also limitations. So it's a software product, it's different. We have a lot of implementers in the world of what comes from Unicode to all the different operating systems and programmers for different apps and stuff like that. So if you wanted a tighter integration, is it likely that you can actually get everyone to do the same thing? Probably not. In situ validation is probably computationally costly. You're trying to do something real time, you're typing. If you're just going off and validating everything, probably it's not the most efficient way to do things. But this ends up putting a tremendous amount of pressure on upstream testing before you release the software, right? That means it puts all the pressure on that, which means you need a lot of good real use cases to develop tests. The problem is, where you're getting those use cases because you're having a hard time creating those tests, or creating those documents that you need to generate those tests. But there are opportunities. I think there's a few things we can improve the user experience when things go bad. We can do a better job mapping the failure modes to improve pre-release testing and then try to eliminate sources of variation. So possible solutions, I don't mean these to be prescriptive. I don't know the ins and outs of all these programs, but I guess I like to consider this lines of inquiry. What if these are things you could do? So one is just for these things where Unicode updates aren't getting into the shaping engine. I guess my question is, what's the risk if you just automatically pulled from one database and dumped it into the other? This may not be great for everything, like a new script, but it might be something that's useful for just a character addition to an existing block. Because not doing it, we know doesn't work. So maybe it saves a little bit of engineering time. This corrective user action thing, I kind of wonder, it's like we're stuck having to do bug reports, but no one wants to do them. We can't find out when things are bad because we can't measure yield. What if you just made it easier for people to fix the thing? So if there was some kind of contextual menu, because we know we have these Unicode formatting characters to move stuff, but no one knows they exist. They're not on a keyboard. The average user doesn't. So if you could just grab it, say, hey, I want to move this guy, move it, and the program says, hey, this is what you're trying to do. I see it. I'm just going to inject this thing in there for you. It's a little invisible to them. And maybe as an added bonus, we can see that maybe if people have opted into additional diagnostic data, maybe this sort of creates an automatic bug report. I don't know the privacy concerns there. This is really the big thing, though. It's I put these high-level categories in there, but I think we have to look at the process inside each one of these and map out all the inputs of the data flow. It goes from point, all through the whole cycle, compare and contrast them across all writing systems that are supported, and then look for opportunities to fix things, which is these kinds of things. So I kind of just wrap it up, is that, to me, the problem is that I just don't think there's enough engineering bandwidth to deal with and support and maintain all the writing systems that need to be supported, right? And so if we're finding things on a bug by bug basis, and it's just going to take forever to fix the problems, and there's so much that needs to be done for new writing systems to exist. And so if we can kind of make the thing more robust, if we make the process more robust up front, we can save a lot of bandwidth to work on new features, which is, I think, what everybody really wants to be doing. And that's it.